The wind howled outside the small cottage, where Arthur and Eleanor huddled under blankets. The power had been out for days, the firewood nearly gone, and the cold creeping in. Their world had shrunk to a single freezing room. Desperate, Arthur remembered a viral video, aluminum foil and salt water, promising miraculous heat. With hope fading, even a fantasy seemed worth a try. Could this simple hack really save them? In moments of crisis, people turn to the internet for answers, sometimes finding hope, sometimes danger. The line between a life-saving tip and a risky myth is thin. For Arthur and Eleanor, the promise of warmth was tempting. But in survival, critical thinking is as important as ingenuity. What's the truth behind the aluminum foil heat hack? Today, we'll uncover the truth behind the aluminum foil heat hack. We'll explore the science, history, and real-world practicality of this viral claim. Is it a miracle solution, or just another internet myth? We'll break down the chemistry, examine the economics, and test the safety. Along the way, we'll reveal how aluminum's unique properties shape its uses and its limits. We'll also show you a proven, safe way to use foil to keep your home warmer. By the end, you'll know what works, what doesn't, and why. Let's separate fact from fiction. Aluminum was once more valuable than gold, reserved for emperors and monuments. Its rarity came from the difficulty of extracting it from ore. That changed in 1886, when the whole Heroult process made aluminum affordable and accessible. Suddenly, the metal of kings became the metal of the people. But every sheet of foil still represents a huge investment of energy. That stored energy is key to understanding both aluminum's usefulness and the risks of trying to unleash it at home. The story of aluminum is a story of science, ingenuity, and the hidden costs behind everyday materials. Aluminum foil feels safe and stable because of an invisible shield, the oxide layer. The moment aluminum touches air, it forms a tough, self-healing coat of aluminum oxide. This layer keeps the reactive metal inside from corroding or reacting with food and water. It's why foil lasts for years, and why it's safe in your kitchen. But this shield can be broken by strong chemicals, like those used in viral hacks. Once the oxide layer is gone, the raw aluminum reacts quickly and dangerously. The viral heat hack relies on stripping away this protection. What seems like a harmless kitchen experiment is actually a way to unleash stored chemical energy. Understanding this layer is crucial to separating safe uses from risky ones. The real story of foil is about chemistry, not magic. The viral hack shows foil in salt water, bubbling and steaming, promising free heat. The chemistry is real. Salt water helps break down the oxide layer, exposing aluminum to react with water. This reaction releases heat and hydrogen gas, but it's far from efficient. The energy comes from the manufacturing process, not from nowhere. To heat a room, you'd need mountains of foil, wasting a valuable resource for a tiny return. The process quickly stalls as sludge builds up, and the heat produced is minimal. It's a flashy trick, not a practical solution. The economics don't add up, and the risks are high. The science is real, but the promise is a fantasy. Viral videos oversell a dangerous, wasteful process. There's no shortcut to warmth here. Some claim the aluminum heat hack is suppressed by secret patents and conspiracies. In reality, the chemistry is basic science, known for over a century. You can't patent a simple reaction, only new, useful inventions. Far from being hidden, this reaction is studied openly for hydrogen production, not home heating. If it worked as advertised, companies would rush to profit. The real barriers are physics and economics, not shadowy cabals. The truth is less dramatic, but far more important. Trying the foil heat hack at home is dangerous. The reaction produces hydrogen gas, highly flammable and explosive in enclosed spaces. A single spark could turn a cold room into a disaster. Many viral videos skip this warning. Some hacks add lye, a caustic chemical that can cause severe burns and blindness. The resulting sludge is hazardous waste, not something to pour down the drain. Kitchens aren't labs, and home experiments can have real, immediate risks. The promise of warmth isn't worth the danger. Safety must come first, especially in desperate times. Don't trade one risk for another. There is a safe, effective way to use foil for warmth. No chemistry required. Aluminum foil is a great reflector of heat. Place a foil-covered cardboard panel behind your radiator, shiny side out. This simple trick bounces heat back into the room instead of losing it through the wall. It's easy, cheap, and proven to save energy. Studies show radiator reflectors can cut heat loss by up to 50%. No dangerous gases, no chemicals, just smart use of physics. This is the real aluminum foil heat hack. Sometimes the best solutions are the simplest. Use foil wisely and stay warm safely. The story of aluminum foil is a lesson in critical thinking. Viral shortcuts promise miracles, but real solutions come from understanding science. True preparedness means knowing how things work, not chasing dangerous hacks. The radiator reflector works because it's based on real physics, not spectacle. Wisdom is quieter than viral myths, but far more reliable. In survival, knowledge is your greatest resource. Respect the laws of nature, and you'll find real answers. When the cold comes, choose understanding over illusion. Thanks for joining us on this journey into the real science behind survival myths. If you enjoyed uncovering the truth with us, don't forget to hit that subscribe button, just like this. Dynamic subscribe animation appears. Join our community for more smart survival tips and myth-busting investigations every week. Stay curious, stay prepared, and we'll see you in the next video.